So we've taken a look at linear programming in several different contexts, and today is review of that. So we're going to take a look at this example and how you can solve it using linear programming. SLP Pottery Shop makes two kinds of bird baths, a fancy glazed and a simple unglazed. All right, so I'm going to underline, we have the fancy one, and we have the simple one. An unglazed bird bath requires 0.5 hours to make using the pottery wheel and 3 hours in the kiln. Okay, there's a lot of colors here. I'll do time, let's see, time in purple for the pottery wheel, and in the kiln is, the oven that they bake it in. Let's use green for that. A glazed bird bath takes 1 hour on the wheel and 18 hours in the kiln. The company's pottery wheel is available for at most 8 hours per day. Okay, so the pottery wheel, I made purple. Oops, that's great. The 3 kilns can be used a total of 60 hours per day, and each kiln can only hold 1 bird bath. All right, so the kilns. So 60 hours per day, and each kiln can only hold 1 bird bath. The company has a standing order for 6 unglazed bird baths. Okay, I'm running out of colors here. All right, so it has to make at least 6 per day. The profit on each of the bird baths is $10 for the unglazed and $40 for the glazed. Oopsies. All right, so just a lot of information here, so I tried to, the unglazed was red. Whoopsies. And the glazed was blue. Okay, so all I did is I tried to underline important information that I think I'm going to need, just so I can kind of go back through it as we organize our information in the table. So we have 2 variables here. We have our unglazed bird bath. So we're going to call those X. That's the number of unglazed bird baths. And the number of glazed bird baths, we'll call that Y. And then the constraints are wheel hours and kiln hours. Those are the 2 things that are holding us back from making just a ton of bird baths to sell for a ton of profit. So let's plug in what we know about what's holding us back. So first, for the wheel hours, let's take a look at the unglazed. The unglazed takes half an hour on the wheel. Okay, so I'm going to put 0.5 for every X, and the glazed bird bath takes 1 hour on the wheel, so 1Y, or just Y. And the wheel can be used for a total of 8 hours per day. So whatever we spend on the wheel, it has to be less than or equal to 8 hours a day. We can't spend more than 8 hours a day on the wheel. All right, let's take a look at our second constraint, kiln hours. So the kiln is, the oven they bake it at to kind of set the glaze. And for the unglazed, it only takes 3 hours in the kiln. Okay, so 3 hours for every unglazed. For the glazed, it takes longer because of the paint, 18 hours. 18 for every glazed bird bath. And there are 3 kilns that can be used at most for 60 hours per day. So I know 60 hours is more than a day, but what that means is, like, for example, each kiln you can use 20 hours a day. So total you'd have 60 hours of kiln time if you count 20 hours per oven. So we can use at most 60 hours. So we'll say that the amount that we spend over here has to be less than or equal to 60. So those are called constraining values. They hold us back from just making a ton of bird baths to make a ton of money. And then we have our profit equation, like how much can we sell each of these for? So if we take a look, the unglazed bird bath is $10. So $10 for every unglazed. And the glazed bird bath, you make more profit. It's $40 because of the extra time spent. And we're going to take a look at what is what combination of unglazed and glazed bird baths is going to give us maximum profit? All right, so we have our table right here. It says use your table to help write the inequalities. I just wrote them right in the table. And then we're going to graph. Now, in order to graph, we have to come up with a scale. And in order to come up with a scale, we need to find points on the line that we can graph. So I'm going to use the cover-up method, and I'm going to show you how we can pretty easily graph these. So first I'll take a look at the wheel hours. So that was 0.5x plus 1y is less than or equal to 8. And I'm going to use the cover-up method to solve. So remember, the cover-up method is when you cover one up and you make an equation. So here y equals 8. There's one coordinate I'm going to graph. And then I'm going to cover the other one up. And I'm going to say, all right, 0.5x equals 8. And I'm putting in the equal sign because these points are on the line. And I'll divide each side by 0.5. So if you take 8 divided by half, that's like cutting 8 candy bars in half. How many pieces will you get? And you'll get 16 pieces. All right, so these are 2 points that are on the line that will form this inequality. All right, so I'm going to keep that in mind, but I'm going to solve the other inequality first just so I can figure out how to scale my graph, because my graph needs to fit both of the inequalities. So we have 3x for our next constraint plus 18y is less than or equal to 60. Okay, let's use the cover-up method and solve. So let's say we cover this guy up, and we have 3x equals 60. We'll divide by 3, and we'll get 20. So that will be 1 point on the line for the inequality. And now let's cover up the x, and we're going to say, all right, 18y, what does that equal? 60. Divide by 18. And I can't do that in my head. Let me grab my calculator. Okay, 60 divided by 18. Oh, it's 3 1/3. So 3.3 repeating, or 3 1/3. All right, so we'll have to graph that. Okay, and then, oh, that's it. Oh, there was one more thing I didn't put in, and that's this. I did it in gray, so it was like hard for me to see. It says the company has a standing order for 6 unglazed bird baths a day. So they have to make at least that many unglazed bird baths. So here's the last constraint. So unglazed was x. Has to be greater than or equal to, was it 6 of them? 6. They have to make at least 6 of them. And so we're going to graph this guy as well. All right, so if you take a look at our numbers, I mean, the highest y value is 8, and the highest x value is 16. Let's see if we can fit 16 in here. 1, 2, 3, 4, 5, 6, 7, 8. No, we can't. So let's go by 2s, and then we can fit the x. Again, the x value has to go to 6. Has to go to 20. So I'm going to go by 2s. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22. Okay. Just double checking. Sometimes I miscount when I count by 2s. All right, so there it is. And then our y values, we can go up by 1. And so I'm going to do that. All right, so let's go by 1s. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so now let's graph this. I'm going to start with this one right here. Using the cover-up method, we figured out 2 points on our inequality, 16 and 8. So I'm going to graph where x is 16 and where y is 8. And notice there is an equal sign, so it's going to be solid. Zoom in here. And again, if you have like a straight edge or ruler, the edge of a paper or book, it's going to be a little bit more accurate. If you use that, that's okay. I want to do it better, I think. Okay, that's better. All right, and then we have to shade it. So our inequality is less than or equal to 8. I'm guessing we're going to shade below. But let's test this point 0, 0 and just see. Is 0 less than or equal to 8? If I plug in, yes it is. So we're going to go ahead and shade below the line. I'll lightly shade because we know we're going to have 3 inequalities to graph, and we're going to look for the feasible region where it's shaded for all. All right, let's graph the green one. So this is the kiln hours. So x is 20. Okay, that's easy enough to graph. 1820. But here we have to kind of estimate, so our graph might be a little bit off. We have 3 1/3. 3.3 repeating, 3 1/3. Okay, so here's 3, there's 4. A third is like right here. All right, so there's 3 1/3. And again, since I'm estimating, we'll be close. We'll be close. All right, so let's see if I can draw a straight line. Okay. I don't like that. Okay, there we go. I mean, that's okay. All right, so now let's shade it. Again, it's a less than, so I'm assuming we shade under the line, but let's test 0, 0. Is 0 less than or equal to 60? Yes, it is. So we're going to shade below the green line, and I'm going to shade the area that's already shaded. Okay, so there it is. Again, here's 0, 0. It's below the line. There's our double shaded area. We got one more Gauss graph here, and that's where x is greater than or equal to 6. Now, an x line, remember, is a vertical line because all along the vertical line, x is 6. So here's x, 6. Let's try to use my line tool here. All right, so this line right here is where x equals 6, and it's greater than or equal to, so we're going to shade to the right of the line, bigger than. All right, so here is our feasible region right here. Let me find the vertices. Okay, so those are the vertices of this feasible region where it's shaded for all of these. So our answer is either on the line or in here, any combination on the lines or inside the triple shaded region. Any of those will work for combinations of bird baths. So let's write down the vertices. So the first one, you go over 6 up 0. The second one, it's 6 and, I'm going to round to like 2 bird baths because we can't make 2-point-something bird baths. And then the next one is 14, 1. And then the last one is 16, 0. All right, now again, any combination of x and y values inside the triple shaded area or on the lines work. But what we learned yesterday with the Lego linear programming problem is if we want maximum or minimum profit, but here we want maximum profit, the maximum profit will always be one of the vertices. And that's why I've been having you find these vertices here. The maximum profit will be one of these combinations of bird baths. So to figure it out, we're going to plug into the profit equation. That's this guy right here. 10x plus 40y gives us our profit. So let me write that down. Okay, so here's the profit equation. 10x plus 40y. It's $10 for every x unglazed bird bath and $40 for every glazed. And now we're going to plug in our vertices, these 4 numbers that I've written in red, because one of these will give us the maximum. One will give us the minimum as well. So again, when doing linear programming, if you want maximum profit, it's always one of the vertices. The vertices are where the lines cross, so those red dots. All right, so let's plug in. Let's do this first one. The profit off 6, 0 equals 10 times 6 plus 40 times 0. 10 times 6 is 60, 40 times 0 is 0. So that, if we make 6 unglazed bird baths, it meets all our requirements, but we only get $60 profit. That's not very much. All right, let's do the next one. The profit off 6 unglazed, 2 glazed would be 10 times 6 plus 40 times 2. All right, so we got 60 plus 80, which is 140, so much more than if we just make 6 unglazed. Let's do the next one. The profit off 14, 1 would be 10 times 14 plus 40 times 1, and so that would be $180. Okay, it's looking good. Let's try our last one just to make sure. So that would be 16 unglazed, 0 glazed. So the profit off 16, 0, or 16 unglazed plus 0 glazed would be $160. And so we can see that this combination right here of 14, so 14 unglazed and 1 glazed will give us maximum profit. So that is the solution to our problem. All right, that is the linear programming problem. So your assignment then is to try one more on your own. The numbers are bigger, but you should still be able to do it. And I did put an answer key up, in case you wanted to check your answer. It's page 45 and 46. Looks like there's two more. And again, if you want to check Google Classroom, I did put that answer key up for you so you can try it and then check your answers.